And you probably remember this fact from Algebra 1. Systems of equations. Yes?
I get it.
Sure, I missed you again, huh? Sorry, Danny. Okay. Systems of equations. When you do systems of equations, see what these are first. See what these functions are first. What would this function give me? If I put it in the right order, a parabola. What will this function give me? A line. How many times can a line intersect a parabola? 2. 1. 0. How does it get 0? By not touching it. Very good. If here's my parabola and here's my line, will I get an intersect? So it can go here. It could go here. It could be touching at one spot. Does anybody remember what it's called when you touch it in one spot? Tangent. Tangent to a line. Okay, now, 2 ways to do this. You could do substitution. You could solve this for y and plug it in. Why would I not want to solve it for x and substitute it in? I mean, you could. Well, there's 2 x's. Good. And you square it, and you have one with a negative out in front. So the easier one would be solve for y. So if I add x, I take this guy, and in place of here, watch that negative sign, I'm just going to replace this. I'm going to substitute in x minus 1. With systems of equations, God bless you, 1 variable, you need 1 equation. 2 variables, 2 equations. 3 variables, 3 equations. So that's how it goes. So I would distribute my negative sign. I would subtract my 1. I'd combine these 2. Just minus 1, minus 1. And then I would factor, solve for x. I would set these equal to 0. And am I done? Got to plug it in. You got to go back and find the y, because this is a coordinate point. So don't forget to go back and find your y. I plug it in. If I plug in a 0, I get a negative 1. Write your solution as a point. If I plug in a 2, I get a y is equal to 1. You could do that way. You could do elimination if you like. If you like elimination and they're set up so that you could add them together and quickly eliminate 1 variable, that might work best. So line these up and eliminate. If I add these together, remember on elimination, you want to add, you don't want to subtract. When I add this together, I get x squared minus 2x equals 0. And I'm at the same place I was here, right? And then I would continue that. So if you see elimination works better for you, you see substitution works better for you, either way. Remember doing these? Did you do any of these in geometry or algebra 2? You did. You kept doing these. Did you do 3 variables, 3? Oh, perfect, perfect. That's as high as we go. 3 variables, 3 equations. Okay. So, next one. Sometimes I'm faced with, well, I can't really substitute, or I can't line them up and eliminate. So there's other things you can look at. Do you see anything that makes one equation a little easier to work with? Or do you see a way? They're all even. I could do what? I could divide this all by 2. Am I allowed to do that? Sure. We can do anything we want. I could solve for x, right? And then what could I do? Substitute. I could substitute it into this guy. And then from there I could solve, God bless you, I could solve for y, and then I could go back and find x, right? So let's solve for y. Remember where you are on one side of the equation or the both sides of the equation. That's usually where the mistakes get made. All right, so y is -2. So I had two lines here. They were both linears. There's no exponents. They were both linears. They could cross once. They could cross none. Or they could be the same line, right? Could they be the same line? Uh-huh. So now I found my y. Nice one, easy one here. Plug it back in here and find your x. So make a coordinate point and you'll get your answer. Now, if you like systems of equations doing elimination, you could do this one with elimination. There's a number of ways you could do this. You could still reduce this one down and do elimination with that one. Like the way you reduced it over there, you could do this one. Just reduce it here. And then maybe just multiply and eliminate the x. Does everybody remember how to multiply top and bottom? Different values? So let's take the easier one. You want to find a multiple, a common multiple, and make one a positive, one a negative. So if I multiply the second one by -5, will I eliminate x? So I would rewrite the top one. Just remember when you multiply all the way across. So I eliminated the x, and I'm back where I was over here. Okay? And then you go back to one of your original equations and plug it in and find the x. This part is nice too because once you plug it in, say you use the first one to check and get the other one, get the x, use the next one to check for your solution that it works. Because you don't have to test them both since you found the other variable from this one. Just use the other one to test it, just to make sure that it works. This is all good? Everybody's comfortable? Everybody's happy? Yes. Good. I'm glad. This is a nice little section. Okay. What do I have here? What kind of functions do I have here? What kind of functions are these? They're what? Linear equations. So I have two lines. So again, they can cross once, they can't cross at all, or they can have all solutions. Anybody want to tell me how to solve it? What would you like to do? Multiply the top by 2. Okay. Let's multiply the top by 2.
Oh, no, wait. That would take away both the x and the y.
Okay, so let's not multiply the top by 2. What would you like to do?
Either if you do substitution, it takes away.
So let's go with this and see why this is eliminating both of these. Oh, sorry, this is a positive. So you're right. It eliminated this one, and it eliminated this one. So what do I get on this side of the equal sign? 0. Well, this should be a 6. Sorry. So when I add these down, I get 0 is equal to 7. Is this true?
No.
So if this is not true, I have no solution. It means these lines don't cross. What kind of lines could they be if they don't cross? They could be parallel lines. So if you think about this, if you solve this for y, and you put this over here, and you solve this guy for x, so solve this guy for y too. Just rewrite these. If you're going to add x, let's just do this one. You're going to subtract x. You're going to divide by a -2. What is the slope? All I care about is the slope. 1/2. My slope is 1/2. I'm going to add 2 here. 2x. I'm going to divide by 4. What is my slope? Oh, my slope is 1/2. What kind of lines do I have? Parallel lines. Will they ever cross? No. So, yeah, if you turn them into each other, they're going to eliminate both. And your last statement says, is this true? Then they don't meet. If this was, say this comes down to this, and it said this, is that true?
Yeah.
Then what? Then what is my solution? All solutions, it means it's the same line. It means it's a line just that falls right on top of it. It's the same line. Okay, so if it's not true at the end, no solution. If it is true at the end, all solutions.
Are we having a test on this in this quarter?
Yes. Yes. I think we only have 10 days in this quarter.
I thought it ends like during spring break.
It does end during spring break. So we only have 10 more days before spring break, like 10 more school days. It ends during spring break. We were just figuring this out yesterday, which is weird.
The test the Friday or Thursday.
So weird.
Well, you certainly want to get this test in because this is a nice test.
No, I'm gonna need that.
Did you make it like way more than the other tests?
We
All
did
right.
all or
So,
nothing, 100%.
Let's solve this guy. Let's solve this one. We have 2 linear equations. Let's solve this one. Last one, guys. Last one. Any suggestions? Solve for y, so how should I do that? Did you want me to solve for y here and substitute?
Yeah.
Okay, so she wants me to solve for y. So I got to get rid of that negative. All right, so y is equal to 2x minus 1. So we're going to do a substitution in here. All right. And now what happens? 2 equals 2. So what does this mean? All solutions. If I solve this guy for y, because we know what y equals here, let's take this and solve this guy for y. Let's divide everybody by 2 first. Does that look exactly like this guy? Same line. All solutions, same line. Yes?
Those kind of problems, you can divide by if you want.
Yeah, absolutely. You can divide by whatever you like, as long as you divide every term by the same thing. Yeah. I mean, we solved it